Okay, here we go. Number one thing, it says it right on top here. Sometimes this happens by mistake. Students don't have a lid or something. You put it in your backpacks and something changes on the settings. You need to make sure that you see a D or a DEG at the top, right? So DEG for degrees. If not, you're going to get the wrong answer. This one has DRG, so it varies. And how you would change it in this one, you press this degree button and you cycle through radians. We don't want that. We don't want grad. I mean, you want to graduate, but we don't want gradients. And we want degrees. Okay, so this one, that's how you would set it. If you have one of my better ones, I like these ones a lot. You would turn it on and check for the D on top here. There should be a little D. And if that's not the case, you press mode. So mode twice, and then just press 1 for degree. And then it's set to degrees, okay? So that has to happen before you do anything else, all right? Let's do some review here. Zoom out. Prior knowledge, things you should already know at this point. Write it down anyways, because it's going to come in handy later on. Isosceles, we have 3 categories of triangles. Isosceles, equilateral, and right triangles. Okay, so isosceles, by definition, with the markings, would say this side is the same as this. So it has 2 congruent sides. Okay. And therefore, guys, did you know that the sides that are the same are going to have angles across them that are the same? That's just a property of triangles, right? So let me make this a little darker, I think. It's just there. So if 2 sides are the same, you can bet that the angles across those 2 sides will be the same as well. It's called congruent. 2 sides are, watch this, it's an equal sign with a third wave, right? That's congruent. Congruent is a fancy word for the same. Okay? 2 angles that are congruent, right? That's what it's saying there. Equilateral triangle. Equilateral means equal sides, right? So all 3 sides will be the same. Therefore, all 3 angles, all 3 angles will be the same also. Okay, that's what the markings, they're actually standing for, all 3 sides. Can we go back to this one here? The first one, you know, the top one, that is different than the other one. So we go like this, right? We go two arcs like that to indicate that the top one is not the same. Okay, so equilateral has 3 sides that are congruent. And this is 3 angles. Watch this. This is my short for angles. 3 angles that are congruent. I want to try to save you time as much. And what would each angle measure? Anybody remember that from previous grades? How many degrees? I don't even have to tell you. It could be the biggest equilateral triangle or the smallest equilateral triangle. What's the number that they... What do all angles in a triangle add up to? Yeah. So if you split 180 equally into 3 parts, not quite 90, right? That would be 260. 3 times 6 is 18, right? 3 times 60. So actually, this would be 60 degrees. 60. So why is this important to know? Well, if you ever see that it's 60, 60, 60, oh, this is an equilateral triangle. I know it. Done deal, right? It's your end of discussion. All sides are going to be equal. All of that jazz. Okay. Now, next one, the right triangle. This is the one you worked with a lot in the previous years. This is the only one you were able to solve. And the box tells you that that's 90 degrees there. Okay. And here I want to review the good old Pythagorean theorem. Do you remember that one? Your teachers tried to drill that in, like you wouldn't believe it, right? What's the slanted side called? Yes, and it's always going to be across the 90. That's for sure. Okay, so this is the hypotenuse. And what are these called? Yes, leg. I'll put a 90-degree in this box because sometimes students just think it's there to look pretty. And it's not. It's saying that that's 90. So this is the shortcut, guys. If you ever want to know the hypotenuse, this is how you find it. Hypotenuse is the square root of leg squared plus leg squared. This is the short, right to the punchline way of finding your hypotenuse. Morning. And if you want to find one of the legs, because remember, they always have to give you two sides, okay? So if you want to find one of the legs, you go leg is equal to square root of hypotenuse squared minus leg squared. Those two I would probably have on my study sheet, just to remember. And this only works with a right triangle, okay? All right, sum of interior angles is always 180, okay? So write this down. So I'll make it look non-right triangle. So this is called an oblique. A, B, C, right? So A plus B plus C is always 180 degrees. Okay, this is a theorem. This is always true. Okay. It doesn't matter what the triangle looks like. It could look like this. A, B, C. It doesn't matter. It could look like this. It could actually be a right triangle. A, B, C. Right? They're always going to be equal to 180. All right, keep going. How is that going to be helpful to us? I think I'm going to I have in my notes something to add here, but I'm just going to bring it up later on when we do the example. Okay. Anybody remember what supplementary angles are? What do they add up to? Don't do this to us, Mr. Dirksen. Like it's been like a summer, right? And I did it first semester last year. Just give me the answers. Just do it. Think about this. It's right to complement someone. So complementary angles add up to 90. Okay. Therefore, supplementary add up to, okay, sum of angles is 180 degrees. That's what you need to remember about those. And how is that going to be helpful? Sometimes you're not going to see it right away, but this is our straight line here. And technically the straight line is, at some point you're saying, hey, around this point right here, right, these two arms make up this angle formed when they join here. And that is 180 degrees. Okay, looks like a flying saucer, right? Let's cut it at any point. So let's say you had it like this, and you knew that this was 150 degrees. What would you say this one is? Immediately, you would say, oh, if this is 150, this must be 30, because this one that cuts into it is joined by that straight line. Okay, so I'm going to actually highlight that in pink, or whatever you have. Right, I focus on that straight line, and I could have 1,000 angles formed along this straight line here. Like I can have it cut. All the angles add up to 180 still. Okay, next. Let's do a real life. You're gonna encounter this. I'm gonna give you examples that at first may seem incomplete. So I will say, hey, this is 120. Right? Start solving this thing. And you're like, I have no angles on the triangle. How can I even start? And then you're like, no problem. Straight angle to the rescue. Right? If this is 120, then this is 60. But really what you're doing, guys, really what you're doing is 180 minus 120. Yeah, you're subtracting. That's how you're coming up with this. You're just not thinking of it because your mental math is so good, right? But that's really what's happening. And I'm going to add complementary here because let's just do complementary angles like this. Sum of angles is 90. You can say it is right to complement if that's going to help you, write it next to it. It is right to compliment someone. It's a cheesy phrase. It's a catchphrase to help you remember. So complementary add up to 90. So how does that work? Well, sometimes, guys, you're going to have a plane flying up on this in the sky, and it's going to look down to the airport. The airport is down here. And do you remember angle of depression and all that stuff? It's depressing, right? Yeah. I'm just trying to be funny here. But yeah, this is going to happen. And sometimes they'll say, hey, the angle of depression is 40 degrees. The angle of depression is 40 degrees. And at times, let's make this dashed as well. At times, it's going to be helpful to work with this right triangle right here. Because when you calculate the height of anything that's up in the sky, you go at a 90 here. Let me zoom into that because it's very small, right? There you go. I'm going to use a different color here because the angle that I'm about to put in wasn't given to you. But if this is 40, then this here is 50. Okay? So we know that because those two dashed lines that meet at this corner, they form a 90 here. So that's how you would deal with that. So sorry, I know I'm overloading you, but I'm kind of just reviewing these things because this will be all coming back throughout the unit, and I want you to have at least heard of it so that you're not caught off guard. Okay. Next, this is a painful, yeah. Zoom in, sure, for sure, Colton. There you go. The next one is I would like you to ace the next part when it comes down to it. The province does that from time to time. Have you ever used the 3-letter notation for angles? I don't like it personally. I feel like it's very confusing, so I'm going to try to help you out with that. How to identify it. So, we're good, Colton? All right. If I go too fast, let me know. I might slow down. I can't promise because this is review. Okay, here we go. Very important. I'm going to highlight this angle notation, right? Angle notation. You're going to have what the knowing 3-letter notation from time to time. 3-letter notation. And the sides, I'm going to use a different highlighter for that. Sides have a 2-letter notation. That one is a little bit easier to wrap our head around. Okay. So let's identify. I'm going to help you identify some of them, and then I'll let you do some of your by yourself. So this, guys, this is a very important symbol. This is angle. That is the angle symbol. So if you have that in front of a 3-letter combination, then you know they're asking for angle. Where's angle ABC located? And what I'm going to suggest to you is just read it exactly the way they state it. Watch. ABC, you start at A, And then you go to B, make a dot there, like A, B, C. A, B, C. So they're interested in this angle right here. They're interested in that angle. The angle that's formed when you connect A to B and then to C. So this one is, let's call this X. That is angle X, and we're going to say, hey, that is the same thing as just saying angle X. I've identified that on my diagram, and I will be all right with you doing that. The province is all right with you doing that, but you need to be able to find it, right? And then you can call it whatever you want. So this is angle X. I've identified that. Try to find the other three angles. So we're going to give it letter, watch this. We're going to call this one Y, this one Z, and this one is going to be K, lowercase. We use lowercase when we're putting it right where it's supposed to be. Uppercase at times, but just put those letters where you think the angle is located. And the side length, I'm going to call this, let's just call it 1, 2, 3. So put a 1, a 2, and a 3 where you think that side is. It's not that difficult, but CBD, I go C, B, D, right? CBD. So it's actually this one here. So this is angle Y. Put the Y right there. What are X and Y, by the way? What two angles do we call them? What do we call them? Because they're along the straight line here. They're supplementary. They would add up to 180. Okay, that's a very powerful concept, by the way. CDE, CDE, right? That's this one right here. So this is angle Z. And then BDC, BDC, right? When you connect those, you form this angle right here, which is angle K. By the way, I could go on and on and on with this. But you need to remember, I could call this one here, I could actually flip it. I can call it CBA. I can go backwards. As long as B is in the middle, you're fine. So because if you do CBA, watch this, CBA, you're still talking about that angle there. So nothing has changed. So you can choose how you want to. One more thing. So try to stay with me, okay? I know it's kind of like a early morning thing. Why would we want to use three-letter notation to refer to this angle, for example? Why couldn't we just call it D, which is probably what you're used to? Well, if you think about it, D has two angles touching it, so you can't just say angle D. Which one of these two are you referring to? That's why we use the three-letter notation. So if you want this angle here, you got to go EDC or CDE, whatever. Just talk about the 3 points that make that angle. I think I made my point. I'm moving on. Oh, 1, 2, 3. Sorry. BC. That's B to C. This stretch right there. So this is 1. DB is this part right here. That's 2. DC is this part right here. So this is side 3. Okay, so we've done side lengths and angles. Side lengths are a bit easier to do. Okay. All right, let's keep going. We're about to start the actual lesson on sine law. Here it is. Some labeling tips. This is on page 3. We use caps for angles and lowercase for sides across the angle. So watch this, guys. If I ever tell you this, draw a triangle DEF and label it accordingly. It's not an angle, right? It says triangle. This is what you're going to do. Watch. You're not going to make a right triangle because most of our triangles are not going to be right triangles. Just do this. Slant, and then make the next slant a little longer because that's most likely going to be your scenario. That's how you start. You just draw an off-center triangle. And here's where it's up to you how you want to proceed. What I do is I start here and I put a capital D, then I go clockwise, capital E, capital F. It doesn't matter if you go counterclockwise or clockwise, it doesn't. You're still going to end up solving the same triangle, right? So D, E, F is are the corners, right? The angles, and then we go labeling the sides. Watch this carefully. The side across this angle is called lowercase d. That's how we know. If I ever say, hey, solve for D, side D, you know you're going to solve the one that's across angle D. And across capital E, this is side E, lowercase. And across F, it's lowercase f. There we go. That is triangle DEF sketched properly. You do not have to put the arrows on an example. If I ever ask you to graph it, don't put the arrows. It's just for your notes. Fun stuff, eh? Next. This is all review, guys. And if you find it new, that's okay. That's all right. We'll work through it. This is very important. Angle of elevation and angle of depression. And this is my best this is my best attempt at making this a visual learning experience. So imagine there's a person. Don't judge me. And let's say the eyesight, or the height from the floor to the eyes, that's a straight dashed line. That's my horizontal. Actually, before we even start, angles of elevation and depression, write this down. Always, this is just me to give you a hint here, always measured from horizontal. What is horizontal? A line that goes side to side. Okay, so here it is. Horizontal, in case you forget, the sun sets in the horizon, right? So horizontal is this, sideways. So that's very important. So this is my horizontal. So if I were to look straight out, that'd be horizontal. But let's imagine there's a bird flying. This is the best I've got. Make sure you write this down, guys. Let's say I'm focusing on that bird, or on the top of a tree, or top of an antenna, or something that's higher up. This angle formed, right, is the angle, right, theta. Do you remember theta? Does that ring a bell? Yeah. Angle, it's like we're talking code or something. Angle of elevation. That's where your angle of elevation is located. And then let's say at the same time you look down, you notice a little bug crawling. Okay. A tick, maybe. Creepy, right? You look down. So your eyesight is now focused on that little tick, right? So this angle right here, theta, is the angle of depression. Okay. And what I'm going to do here is to help you out. I'm going to highlight horizontal with whatever color you have. And then I'm going to go over here and highlight that horizontal line with the same color. It's like both angles were measured with respect to the horizontal. So I'll give an example. Pilot spots the airport. Write this down. The pilot spots the airport at an angle of depression of 30 degrees. Is that too small? Can we zoom in? I'll try a little bit so that everything is still visible. So let's say you have a pilot spots an airport at an angle of depression of 30 degrees. How would you sketch this triangle? I'm not going to pretend to draw an airplane because it's gonna be bad. Okay, but let's imagine this is the pilot up here, and the pilot is looking out and spotting the airport. Right, so airport, pilot. So that's something that you should be able to wrap your head around. That's what's happening. You're higher up. You're spotting the airport. Where is the angle of depression? Where would you put it? Where would you put the 30 degrees? So Dirksen, it's just a slanted line. Like I don't even have another line to put it between. Because remember, it has to be in between. What does it say? You're going to go back to your notes perhaps. And angle elevation depression, they're always measured from the horizontal. So go back to the pilot and imagine there's a horizontal line. Like the plane is still flying this way. Right? This is the horizontal. And so the 30 degrees would go in here. That's where the 30 degree comes in. Guess where most students want to put the angle of depression? Most students, or not most, I would say a lot of students would draw this down and they would put the 30 in here, and that is wrong. I'm going to say, right? This is wrong because there's no horizontal there, right? If you were to put the 30 there, let's make a dashed line here too. That's a vertical, right? Going straight down is a vertical. That's not where the angle of depression resides, okay? I hope I make that clear with that example. I just made it up, by the way. I didn't have that as part of my original notes, but I was reminded of the fact that a lot of students get that wrong when they're supposed to sketch it. Keywords. If a tree is due east of you, if the question says, hey, there's a tree due east of you, let me zoom out a bit. There. This word, due east, that's what you need to focus on. Something is exactly east of you. So you need your compass rose. I hope you remember. Right? North, south, I hope you know that one. And then east, west. Where is east? Here? Here? Okay, I'll tell you this. I know that your teachers in elementary or have tried never eat soggy wieners. I will just say this. Everybody remembers north and south, usually. Just say this has to spell we, not you. Right? If it says ew, then it's like ew. Don't do it. Flip it. Anyways, I'm trying stuff here. So if a tree's east of you, then, right, this would be you, and the tree is right here. Let me try this. I think I can manage. Hey, right? So this is exactly east of you. It means, right, it's going to be straight across. You're going to be looking at it, and that's where it's located. Another one. Guys, this is going to come up, and I don't want you to be stuck with this, but if you walk 7 kilometers per hour for 3.5 hours, come on, how far will you have traveled? It's a straightforward question, by the way. If you walk 7 kilometers per hour for 3.5 hours, how far will you have walked? It's kind of like, let me try this. If a mechanic charges you $100 per hour and the mechanic works on it for 3.5 hours, what would you do? $100 per hour, right, times 3.5. Same here, 7 kilometers per hour, 7 times 3.5. 3 times 7 is 21, right? And another half, 24.5. You can double check me. Yeah, it's 24.5. Check, right? So don't let that stomp you if a question ever says that. This is what they're after here. This is what they're really giving you. The side of a triangle is this, right? Like if they give you a speed and the time, it's the equivalent of 24.5 kilometers, that side of the triangle. It's going to be, now we're going to start our new segment. This is, the next part is no longer review. Okay, and again, if some of this seems brand new to you, that's okay. Just write it down. Try to internalize it. And I did go a little fast. I will take that. But some of it I will explain again when we get there. I'm gonna stop this here and just start.